There we are. Starting a little different today. Hey, Verge.
Hi, Mark.
We just wanted everyone to appreciate the little Reddit video we got. So,
Yeah.
all right, let's go to where we normally go. Let's see. Hey. So, hi, Verge.
Hi, Mark. Welcome to our last AP Live. I hope everybody has their tissues with them because there's going to be
I think I've also reused every transition at some point today.
Okay. So. It's our last lesson.
Yeah. And there's a note from yesterday.
Uh-huh. So. It's been a good run. It has been such a great run.
That's it. That's the whole slide.
Uh-huh. Aww.
Yeah, Verge hasn't seen my transitions today, folks. So,
yes. So I'm watching for the first time too.
So what are we here for? Next Tuesday at 2 o'clock Eastern, same time as now, you will be taking your AP Calculus exam and you will be killing it. And if your internet kills you, then you'll be taking it on June 1st, but that's not going to happen. Here's our links again to the exam walkthrough and the testing guide. Please, if you haven't looked at them yet, start immediately. And we are going to go through one last time, right? Your 5 steps to get ready for the exam.
Yep.
Try the exam demo, complete the exam day checklist. Go find your background for the very last time, right? Mm-hmm. Confirm your email address. Locate your e-tickets. If those you take in Monday exams, those e-tickets will be there on what, Sunday?
Tomorrow.
Or on tomorrow, Saturday. Ours will be there Sunday. Yeah.
Ours will be there Sunday. So for calculus, if you don't get that email with your exam ticket, go to that My AP and get your e-ticket in there, your exam ticket in there.
And check in 30 minutes early. You know, you guys have to have Grammarly disabled on your browser if it's enabled on your browser, things like that. Get there 30 minutes early so you can take care of that stuff and just relax and get your space situated and all that good stuff. Mm-hmm. Again, decide how you're going to take it. If you're going to take it on computer and you're going to do side by side, start practicing that way with your browser and whatever you're typing in. Same if you're submitting a document. These are all taken from those great things that are on AP, and we have all those links at the end. If you're doing a docx, a PDF, or a text, there's a button for that. And if you're doing PNG, a PNG, a JPEG, or JPEG, there's a button for that. Those are the formats. No HEIC, no GIF, GIF, any of those. So.
Yeah, and make sure you practice the demo several times.
All right.
Oh, here's the demo screen.
Yes, and it's a 2-step process, right? You have to attach your file, upload a photo, or paste into your field, and then submit. And you have to submit before time runs out. The upload can continue in the background, but it has to have been begun. So. My, what is this? We haven't done this in a while.
What do you mean we're gonna do work on our last day? Give me a break, Mr. Corrali.
That sounds like the end of every school year I've had. 28 of them. Or 27, I don't know, something like that. Yes, we have a last warm-up, so let's read it.
Yeah, and definitely if you haven't already, there's a couple things in the shared folders. One is the calculus salad. It's basically a little problem set that we put together yesterday afternoon. We'll talk a little bit more about that later. And there's also a last circuit, so you might want to access those before the video goes on. So here, today, particle moves along the x-axis.
Sorry, I had to mute myself there. The family is, my wife's taking my daughter on a walk and they're walking by. Sorry, yes. Would you like to read it, or do you want me to go?
I'll read it. A particle moves along the x-axis. The velocity of the particle is modeled by a strictly decreasing, twice differentiable, got to move our pictures out of the way, function v of t, measured in meters per second. Select values of v of t at specific times t measured in seconds are given below. It is known that at time t equals 7, the particle's position is 3 units to the right of the origin. And we've got this table here with T and V of T. And then we've got estimate V prime of 2.5 and V prime of 6. Interpret the meanings in context and include units. So the reason that we wanted to do this warm up is that we didn't ask any of these questions of this nature on either of the 2 mock exams, just because we were so crunched for time and space and quite numbers of questions. But anyway, so we're like, we got one last day. We're gonna make sure that we review this skill because it gets assessed frequently.
Yes.
So Mark, you're gonna go ahead and grab that?
Yeah.
Okay.
And I think, yep, hold on. You're probably going to see some gray boxes. I actually did not have my camera turned on. Always prepared for the last day. It's actually funny. I was actually ready early today, which I never am. I was like 12.
Oh, that's the kiss of death, isn't
12,
it?
15, 12, 20. And I was thinking like, I actually had a little nerves and I was like, I haven't had nerves once. Like it is the last day.
Oh
like,
no, I was very nervous the first few days. Remember when our producer used to say, does anybody have to go to the bathroom?
That's true.
Before we would go live, I'd be like, I do. But yes, I've kind of relaxed, and that's been the great feedback from the other teachers and the students throughout our 6 weeks or 6.5 weeks of this.
Yeah, whatever it's been, 30 some days.
Yep.
All right, so V prime, also known as acceleration. That might be important, but V prime at 2.5. Well, I don't have a 2.5 in my table, but I do have a 2 and a 3. So rise over run, I'll put my function values on top. So we're gonna do 1 minus 3 over 3 minus 2. And if you're asked to do this on an AP test, they want to see that quotient and that difference. They want to know where these numbers came from. They do not want to just see -2. And it's meters per second on top and then per second again. So meters per second squared. All right, and then 6.6, sorry, not 6.5, is going to be very similar. So -6 minus 0, my velocity values, it's 7 and 5. And I want to take that closest interval around the unknown point. I don't want to say, oh, 6 is between 3 and 9, so I'm going to use that. I want to see what's going on as close as possible, right? Local linearity.
It's all about the local neighborhood.
Get close to that local and instantaneous point. And that one will be -3 meters. And of course, I could have left them as these quotients, right? And just put meters per squared on each of those, or meters per second squared on just those. Oops, my camera froze.
Yeah,
you're still moving. There it is. Okay. So yeah, but I could have left it here and just written meters per second squared on that. So the interpret, so at time t equals 2.5 seconds, the particle, the particle's velocity is decreasing 2 meters per second squared. And you'll notice I didn't put a negative on the 2, but I did.
Because of that word decreasing.
The word decreasing is a signed word. And that means once I use a signed word, I have to just have an absolute value here. I can't even say decreasing and negative if I mean increasing. You can't get clever like that. And then at time t equals 6 seconds, the particle's velocity is decreasing -3 meters per second squared. What could I have said instead of particle's velocity, Verge?
You could have said the particle's acceleration is approximately -2 meters per second squared.
Right. Yeah.
You wouldn't want to say acceleration is decreasing.
And I wouldn't want to say increase or decreasing because then I'm being a jerk. Because that's the change in acceleration is. But if you just say the acceleration is, then those signs do come back up. And I put a negative on that 3. I should not have put there.
Oh, I'm glad you noticed that.
I was thinking ahead to acceleration. But yeah, if you're talking about acceleration, then you can have a negative acceleration, but you can't be decreasing at a negative. That's just silly. And if any of the physicists want to argue that with me, my argument is not a very strong one, but it will be, you're just being silly.
So you want to go back to the PowerPoint and tell folks why we, here's this very familiar slide.
This is what we do after the warm up, right?
Yeah.
What are you doing here if you need introductions the last day?
Yeah.
All right. So we've done all this.
Hmm.
What's left? And we're gonna say goodbyes. We actually have a video to watch. So it's not all calculus, but there will be calculus because it's who we are.
Yeah, because like, if you're going to have a last fun day, like, of course you're going to do calculus. It's one of my favorite things to do. So, and we have your attention for
Right.
a few more minutes anyway.
So what we're going to talk on these last two bullets is, what did we miss on the mock exams? We gave you two very thorough exams this week, but they were both 45 minutes long. And there was stuff that's in the curriculum that was not there. Oh, I just got a text about the negative on the 3. Beat you.
Well.
So I actually was curious. I was like, why haven't I gotten a text yet? So I'm glad to know you're still watching. Hi. I know she waves back. So, anyway, so what did we miss on the exam? Because we went through and I think we found 10. Is that right?
Yes.
And so
yes,
and
that wasn't necessarily an exhaustive list, but those are the things that came to mind quickly.
Yeah, and we went back and I opened up the last 3 years and we went through the free responses. Now we didn't go through all the multiple choices, but we found 10 that we felt could have been tested and we didn't. And then we're going to have our last practice with us today. And I did say with us because it shouldn't be the last you practice ever. That would be weird. All right, so here's our list. Do you want to read that?
Sure. Well, and again, like when we've been preparing these lessons, we've been 100% collaborating on stuff. And so yesterday, after we went over everything, and when we got back together and met about 4 p.m. our time, we came up with a big list of things that we felt like could have been asked, but we didn't get a chance to ask them. So, estimate the derivative from a table and interpret derivative at a point with units in context. We just did that in the warm-up. Like, we didn't do that on the mock exams, but I, as somebody who's looked at a lot of AP exams in the last 30 years, and more particularly in the last since the curriculum redesign, I think that's for sure fair game. Is the particle speeding up or slowing down? We kind of asked about whether certain rates might be increasing or decreasing. Am I right about that, Mark? But we didn't really ask about with respect to velocity.
Now, as Virgil's going through this list, we did do all of these during our 6 weeks.
Oh, absolutely.
So don't be like, they're mentioning this now. It's not.
No, we just didn't explicitly test it on either of those 2 mock exams. So we haven't talked about it since like last week at the earliest.
Yeah.
Tangent line is an underestimate or overestimate, and why? Same with Riemann sum. When you calculate a Riemann sum, did you actually get an underestimate or an overestimate of the true area, and why? What about a slope field? We didn't have any slope fields on our mock exams. We spend a lot of time on slope fields when we were teaching Unit 7. We think those are going to be kind of hard to test this year, but you could still have to talk about one in a 1 or 2 sentence explanation. So I would go back and review some of that stuff for yourself. By the way, you should take a screenshot of this. And derivative of an inverse, that could happen, especially if it's caged as a chain rule problem, right? I mean, like, or hidden.
We actually did a couple of those last week, so I know we've done that recent.
Yeah, not differentiable at a point.
Defending it, right?
Yeah, intervals of increase and decrease, and intervals of concave up and concave down. And with that in mind, overlapping intervals, like where is this increasing and concave down, something like that. We didn't do that on our mock exams. Overlapping intervals, 2 particles going the same direction or opposite directions. And then more with the analytical behavior.
That was you actually mentioned that.
Yeah,
you mentioned that one above.
I did.
And by the way, if anyone's distracted by the movement back here, this is. Did I mention this yet?
No, but I'm sure everybody's noticed it.
It's the 32 backgrounds in order. From this experience. So yeah. Okay, so here's what we did. We wrote a practice problem that we're going to look at today. It's the one in the Dropbox that Verge mentioned. And I know some people are going in that Dropbox going, where are those answers from mock exam 2? They'll be there after the show today. That's been our habit, 48 hours. But we have a problem for you that covers these bracketed pieces. And you've already done the first one. And we didn't tell a joke during the warm-up. I don't know if you had something for that.
I do have a joke.
Okay. And then these blue checks, it's your last homework from us. This weekend,
this weekend. So when we say homework, we mean definitely go back and see if you can find examples of those. Maybe you'll even get to meet with your teacher, and your teacher will be able to find some examples of those for just doing some additional practice. Personally, I think you should. I think I always get good practice by doing problems I've already done. What do you think, Mark? Is that a good?
Sorry. My family decided that this was the one they weren't going to go back in our room, and now they're yelling stuff at me. So I was distracted as I started to say this was your last homework, and I'm sure you covered it. But yeah, I'm sorry about that.
No, but I was just saying,
sure they will be sorry about it soon.
Instead of in terms of studying for the exam, and Mark and I are both of the mind that to have like a 6-hour Zoom session with your class on Sunday to help cram for Tuesday is not helpful. But I like to practice stuff I've already done, actually become more fluid with it. So take those mock exams. Yeah, get really good at what you're good at so that you can do it quickly, and then you can spend more time on the other stuff.
Absolutely.
So after we did this yesterday, we said, well, we got to write another problem. We're getting pretty good at that, Mark, aren't we?
And here it is.
And here it is.
As I was trying to say, it is in the Dropbox already. So if you need to pause this
and there's actually a part F as well, which isn't showing on the slide
right.
here.
Sorry about that.
No, it's fine though.
That's fine. Hopefully you're not reading off this anyway, because we're gonna pull the screen down and do it on paper in a minute anyway.
Yeah. So and again, like in terms of the 2020 exam, we really think you're going to see a table. You're going to have to answer a bunch of questions about it. You're going to see a graphical stem. You're going to have to answer a bunch of questions about it. So those are great problems to practice. And this one is something that we threw together with all the ingredients that we needed. That's why I called it a calculus salad when we were done. And, anyway, Mark is going to go ahead and do some of these problems with us. And I'm going to do some after that, right, Mark?
All right. Yeah, and if this is also the last day, whatever. I got like 5 messages over here now, and I don't know if any of them are relevant to what we're doing now. So if you really wanted me to say something, oh well.
Don't message me. I'm in airplane mode.
Yep. So, all right. So we have this table that we used a little bit for part A. We've already done that. Actually, I've got part A right here.
You might actually need it close by to do part B.
So part B, and my name, page 1.
Oh, he's got his APID on there.
Get my APID on there, right?
Mm-hmm.
Yep.
Oh, by the way, if you haven't heard us say that, prep your pages like this weekend. Get your little clip together. Here's my AP Calculus pages. Here's my AP Physics pages, whatever. Get them all kind of clipped together for yourself. I'd say at least 4 pieces of paper. Okay.
Yep. Yep, these are all nonsensical messages. It says,
part B.
State whether the particle is speeding up or slowing down at both t equals 2.5 and t equals 6. So speeding up, slowing down, I want to be looking at velocity and acceleration. So I have these approximations for my velocities, but I actually know that the velocity is always decreasing, right? They told me that up in the stem.
It said strictly decreasing.
It's strictly decreasing. So we know the velocity is less than or equal to 0 for all t. Sorry, jumped into Shane there for a second. For those of you that don't know the upside down t. And our approximations are -2 and -3, so I feel pretty confident those. We wrote this yesterday. I think if I was gonna, if this had made it to a mock exam, I would have said, using your approximations in part A, determine whether the particle is speeding up or slowing down, so that we could assume these are negative values. And then I need to look at A. So A of 2.5 is going to be V prime, and V is not less than V prime is less than.
Sorry, Mark, that was my bad. I didn't catch that. Yep.
So A of 2.5 is V of 2.5, and that is less than or equal to 0. and probably less than in all honesty, based on our data, right? Because these A's are what we found up above. And so at t equals 2.5, let me scoot that up. At t equals 2.5, my velocity is positive. How do I know my velocity is positive?
At 2.5, because the velocity is going from 3 to 1, and this is strictly decreasing. So we know that it couldn't have gone like way down to like negative whatever, or way up to positive 10 or whatever. So I can definitely assume that my velocity is positive in between 2 and 3.
So I'm going to say my velocity is greater than 1, which is greater than 0. And A of 2.5 is less than 0, or at least our approximation is. So the particle, these are opposite signs. So the particle is slowing down. I already said at t equals 1, so just slowing down.
Mm-hmm.
And because what we're saying, the velocity is getting closer to 0, right? That's really what we're looking for. If the velocity is getting closer than 0, the speed is getting closer to 0. And then at 6, I'm going to start a new line. And this is going to model it very similar, isn't it? We already have A of 6 above, right? We're assuming that's less than 0 based on our approximation. And then V of 6, well, it's going to be decreasing between 0 and negative 6.
So negative, yeah.
So it's going to be less than 0. They're both negative. So at t equals 6, the particle is speeding up because it's moving, the velocity is moving away from 0. So if you want to think of it as going in reverse in a car, the velocity is getting more negative, and so the speed is going up.
Going reverse in a car, like Dukes of Hazzard style.
Yeah.
Not like grandma backing out her driveway. Maybe grandma backing out her driveway. I don't know.
I'm just wondering if the Dukes of Hazzard movie might be too old of a reference for our modern high school students.
Well, I was really just talking to you.
Oh, okay. Yeah.
There's probably only like 10 people watching right now.
I think what's so beautiful about that is you don't know this until now, but I had a poster of Bo and Luke Duke in my bedroom.
I believe
back in like 3rd grade. Yeah. My best friend was Paul then. I have no idea what happened to him. He moved away like in 4th or 5th grade. So Paul Bond, if you're up there, hello. C, the particle's position is modeled by the function p of t. Write an equation of the tangent line to the graph of p at t equals 7. Use the tangent line to approximate p of 8. Well, we have done tangent lines. That should not be old, right? So
but
we need a slope
and
a point.
This problem is so great because this is a tangent line in context, and it is a little bit unnerving. Like, yeah. So where would I find the slope? Yeah, the slope is actually going to be the velocity.
And then p
that's
prime
tangent
of 7
to the
is
position
v of 7.
function.
Oh, that's the negative 6.
Yeah, p of 7 is actually. I can't.
If I'd been like this the first day, none of you would be here 30 some days later. All right. At t equals 7, the particle's position is 3 units to the right or more. So the position is 3. There we go. And so my tangent, I actually have a cheat sheet here and I'm not using it. Perhaps I should. So the position is 3 plus my slope times x minus 7. So there's my tangent line. And then p of 8 is going to be approximately 3 minus 6 times 8 minus 7, which is good. It's done if I want to walk away. But that's going to be 3 to the left of the origin. They didn't ask me to phrase it that way. I could just say, they said approximate p of 8. So I say negative 3. I don't have to give the position in terms of the origin.
Yeah. You know, this is a very long number line. If we have 3 meters to the left of the origin.
That's true. Usually don't give units when you're talking about the x-axis. That is kind of funny. And x-axis, draw it on the ground outside of football.
It's like a human number line or something. Yeah. Wait a minute, it's 6 feet apart, right?
So D, is that estimate an under approximation or an over approximation of P?
Ding, ding, ding. This is one of the things that we definitely need to talk about. Well, all of them are. They were on the list.
I want to look at P prime. P prime is equal to V prime.
P double prime.
Yes. Oh, I wrote double prime. I said
Yeah.
P double prime is equal to P double prime is equal to V prime, which equals A.
Mm-hmm.
V prime is strictly decreasing.
Mm-hmm.
So we're less than 0 or less than or equal to 0. It can be 0 for an instant. Individual.
It's not going to stay 0.
Like a negative x cubed curve or something might happen, but it's decreasing the entire time. So since V prime is strictly decreasing, P is concave down, right?
Mm-hmm.
And I always do this. I have them memorized now at this point just because, but I always just draw it really quick and go, okay, where would tangent lines be on this? And where are all those tangent lines?
They're above the graph.
So B of 8 it was approximately -3.
Mm-hmm.
Was an overestimate because our tangent lines are going to be above that concave down curve.
Yeah, an over approximation or an overestimate, either one.
Yay. So that's kind of fun. E. You want to say something about names on AP tests?
So if you see a name on the AP exam, for calculus anyway, I can't speak to any other subject area, it is a name of a real person. So some of you might have studied the Karen and Larry problem with the bicycle and going to school. Like, those are real people. And this person here, Claire, is a real person. And she is our producer. And we want her to come out and say hi before we do this problem. So Claire, can you come on out so we can clap for you?
Bert, you didn't tell me you were going to put me in a problem, but I'll take it. I'll take it.
I'll tell you, she didn't.
Oh, man. Okay, but I'll take it. I'll take it.
Mark actually said, should we have Claire do the problem? And then he quickly retracted that statement and said, that would not be fair. She hasn't taught AP Calculus in like 6 years. So
that is true, but I'm pretty sure I could do this one. I'm not going to put myself on blast right now, but yes, I did teach AP Calc, AB and BC and stats for a couple of years and mechanics, physics C. So, but I am a little rusty, so I leave it to the pros. That's you guys.
And all I have to say about that is it's obvious that she loves us best because she's produced lots of these videos. Like, if you've watched physics, right? Like, you've done the physics ones, you've been the producer for that. But we know she loves us best, right, Mark?
Okay. Yes, absolutely. And you don't have to say it right now. It's fine. You don't have to confirm.
It's totally fine. I'm going to let you guys do what you do best and just wish everybody who's watching good luck on their exams this week.
Thank you, Claire.
Thank you.
All right. So I'm going to do the same thing I did the last one. And like I said, I should have all these memorized, but I always just draw the situation. So that
I drew mine too, actually.
Yeah, we know it's a decreasing function, right? And it doesn't have to be concave down or concave up. We do kind of know because of some stuff, but I'm just going to draw a wiggly line. And then I'm going to draw left Riemann sums on that, which means the left side of the rectangles are attached to my curve. And she did 3 subintervals, did 6, whatever.
It's not going to matter. You can
where are the rectangles? Where are the rectangles?
They're all having this extra little bit above. So this is another overestimate.
Yeah. And it says, how do I know? And it's because it's a left Riemann sum on a decreasing function.
Sometimes, given your information, like sometimes you're given that like f prime is less than 0. So you can't say that f is decreasing unless you go back to the information in the stem, like f prime. How did you know that? You knew that because you were given f prime is negative. So he's using the information he was given.
Say on V, which V, we were told V was a strictly decreasing function. Yeah.
Yeah. And notice how you didn't even have to make a calculation. I think this is a great question for this year's AP exam because it's a conceptual understanding of what's going on, not necessarily like a brute force calculation. So a right Riemann would be
Right
an
would be under.
underestimate.
And then trap, you don't know. Trap depends on concavity. So
Yep. Trap
if
depends on cat.
if you had a continuous concavity, we could, but we don't know anything about that. So
well, we do know about the concavity actually.
We know about P's concavity. We don't know about V.
Oh, okay. That's
V's,
true.
So
that's true. Okay.
And then F.
It's a great question. I'm just in love with all these questions.
All right, so we have another particle, Q, is also moving along the x-axis. Oh, and this is not the fixed one. Dang it.
Well, they probably have the fixed one in the Dropbox.
No, this is probably the Dropbox one. Those are supposed to be T's.
Oh, wow.
It'll be fixed within an hour. It's the independent variable you get, but yeah, it's talking about moving along X, so it should not be in terms of X. It says T down here, but Q of T is 4 plus 5T minus T squared. During which open intervals on 2,9 are they moving in the same direction? Well, I already know if I look back at my table, V is always decreasing, so it's only going to be 0 once. And it is positive up until that 0 and negative after. So when does it change directions, Verge?
Changes directions at 5, T
at
equals 5.
So for P is moving right as positive velocity for T less than 5. And it's moving left for T greater than 5. So we've taken care of P, just like Verge when she was nervous before the things, I guess. Yeah, potty jokes. I can't pass a potty joke up. All right. So Q prime, that's going to be our velocity for Q. So this is V of Q. And it is going to be 0, subtract 5, divide by negative 2 at 2.5. And I'm just going to do a quick sign chart just for my own. To the left of 5/2, this is going to be positive, and as soon as we get bigger than 2.5, it's going to be negative. This is not my justification. This is completely for my thoughts. This is.
And notice how it didn't say justify either.
No, it doesn't.
And it didn't even say show your work, but you would have to show work before you declare an answer on any part of any free response question.
So it looks like, and we're only looking from 2, right? From 2 to 9. So from 2 to 2.5, Q prime is moving right, and from 2 to 5, P is moving right. So, and they said open, and they said open intervals. So 2 to 2.5, P and Q are both moving right. And then this is left from then on, and P joins it moving left at 5. So from 5 to 9, P and Q are both moving left.
Nice.
All right.
Well, I never told a joke.
No. Well,
so I'll tell one right now as I'm grabbing the screen here, because I'm gonna go ahead and do a few more things with you guys.
You're gonna grab this. Do you want to? Let's see, 135. We got that. You want to do a couple circuit problems and then go back to the slideshow? Or do you want to talk about the exam a little more and then do some calculus?
I'm going to tell a joke, and then I'm going to do 2 problems from the circuit, and then you can grab it back and do all the videos. We've got 2 videos for you guys, and then Mark has some other stuff you might want to say too, right?
Yep.
Okay.
Cool.
All right. So let's see if I can do this. So my joke was that parallel lines so much in common, including their derivatives. It's a shame they'll never meet. So that's a very Algebra 1 joke. And actually somebody sent it to me, parallel lines have so much in common, it's a shame they'll never meet. But then I put in there, including their derivatives. So I made it into a calculus joke. All right, anyway.
But is that sadder than the 2 lines that touch and then grow apart forevermore?
I don't know. What's your we, Mark? We've been living these parallel lives existence. I don't know. So I did my last live. So sad. And I want, before we do a few more calculus problems, I want to share a few things with you guys. As this whole process began, our counselor sent this out to everybody at our school, and it's a quote from Aristotle, so a Greek philosopher from thousands of years ago. "You will never do anything in this world without courage. It is the greatest quality of the mind, next to honor." And I was very frightened at the beginning of this whole process, because I was like, what in the world are we getting ourselves into? And we just kept moving forward, didn't we, Mark?
Yes,
This is my new.
That's a slightly slightly more recent quote. We just kept swimming, right?
This is my real recent quote. Haters gonna hate, and there's nothing I can do about that. So we're just gonna keep moving forward. I woke up this morning, and I am a big Hamilton fan, in addition to all things musical. And I started writing this parody, which I cannot sing for you or play for you because YouTube will cut out the music. So just know that there's a fun parody that goes, something like, "One last time, prep for AP Live with me one last time, and then we'll teach them how to score a 5, you and I." And then it's like, when they say George Washington's going home, we can say Mark and Burge are staying home. Calculus has its eyes on you. Okay, all of my Broadway nerds are geeking out right now. Anyway, and then there's this part. I forget that part. Okay, whatever. We did this already. Okay. My last day in calculus, my students, we usually just kind of hang out. We talk about what to do and what not to do on the exam. And we do this last circuit, which is called the last circuit. And it's in the Dropbox there for you. And it's very straightforward. This question right here, number 10, you didn't have to do this year. Mark, I think you had made a note of that, right?
Yes, it's actually crossed out and replaced with what is the inverse cosine of pi, I think, or something like that.
Or 0, maybe. 0, I think. Okay. But I did want to do a couple with you. Just, it's my last chance to go ahead and do a few circuit problems with you guys. And this one happens to be number 7. And it says, find the instantaneous rate of change of g of x's function natural log of x plus 3 at x equals a half. And this word instantaneous rate of change, I feel like I haven't said that recently. And so I wanted to say it one last time. What would I do for instantaneous rate of change?
The only skill you had for the first 2 months, differentiate.
Right. But if we had to find the average rate of change, we would have to do our, y2 minus y1 over x2 minus x1 type thing. So anyway, yes, differentiate. And this is a natural log function where I have to be careful about chain rule. But what happens when I multiply by the derivative of x plus 3?
You get another 1.
You just get 1. So I'm not even going to write it down. And then g prime of a half is what I'm being asked, because that's the instantaneous rate of change of g at a half. And then this is 1 over a half plus 3, which is 1 over 3 and a half, which is, I don't know. Is this right? 2 sevenths maybe? Okay. This is a really sweet last circuit. And these are the kind of things I hope that you do this weekend. Just do some gentle problems. You know what I mean? Just keep yourself fresh. Don't freak out.
It's the pregame stretch, right?
The pregame stretch, right, exactly. All my athletes out there, my musicians, you don't want to, like, my own child is a horn player. And if you're going to have a big audition, you don't want to blow yourself out before you have to go into that room for the audition. You want to be ready, but you don't want to be like overdone. This is another one I want to do for you. And then I'm going to go ahead and give it back to Mark. But this one, number 9, says find the particular solution y equals h of x to the differential equation dy dx is equal to x squared over y with initial condition h of 0 equals 1, and then find h of 3. This is a biggie. You guys need to practice separation of variables, finding particular solutions. We've done a lot of them, but there's always another one to do, right? So separate. So y dy is equal to x squared dx. integrate. So you get here 1/2 y squared is equal to a reverse power rule again, 1/3 x cubed, and then plus c, that coefficient or constant of integration I meant. Substitute in 0 for x and 1 for y. So 1/2 times 1 squared equals 1/3 times 0 cubed plus c. C ends up being 1/2.
Job.
And thank you. And then rewrite.
Just know I was here.
Yeah. And I want to find the particular solution. So I still want to solve for y. I'm going to multiply both sides by 2 and then take the square root of both sides. That's my plan anyway. So y squared equals 6 x cubed.
Times 2.
Sorry.
You just did that to make me feel better.
2/3 x cubed plus 1. No, I did this wrong earlier. I don't know. Maybe I didn't. I got the right answer. So, okay. Take the square root of both sides. And I get 2/3 x cubed plus 1. When you do take the square root of both sides, you really have both of those branches, but you want to declare the positive branch. And then I'm going to use it. That actually is my h function to find.
And she's declaring the positive branch because she looked back at her initial condition. So if she plugs in 0, she needs to get +1 back.
Yes, very good. And we did that back many, many times, but we haven't said it lately, right? So plugging in the 0 here, I need to have an output of +1, not -1. That's why I select that positive branch. And here when I do 3 cubed times 2/3, I think I get 18, and then +1, I think I get 19. So this ends up being root 19, and that advances you in the circuit.
Excellent.
And you can next one. That's something that would be a good thing to practice. In fact, my students need to send me their work on this tomorrow by 6 p.m. If you're watching on Friday, that would be tomorrow, Saturday by 6 p.m. But all other teachers, students, I'm not sure.
It's not our place to
care.
say. Do what you want.
Do what you want, right? All right, Mark.
All right. So back. I have no idea what's here. Oh, okay. We still have, we're going to, wrap up a little bit here. We're 142. We're not going to get done at 145, but we'll be done soon. We have a really great video we want to share and, of course, say goodbye. But e-tickets, just so you guys know what these look like. I've had a lot of people ask, and they've mostly been teachers, but is the ID number your ticket? It's like, no, you can go get your ID number right now from your profile in MyIP. In fact, go get it, write it on some paper.
Yeah, prep your paper.
It is here on the ticket, but this go to exam, this yellow box here, that's actually a button. Like in the email, it'll be a link. On MyAP, it's going to be a link. And when you push it, it goes to your exam. And it says, 30 minutes ahead of time, go early and then set alarms so you don't fall asleep. But
well, I think they actually need to do things early. Like they need to verify.
Well, yeah, you need to log
things.
in and you put your name in and which exam you're there for and all that good stuff. So
yeah, there's some stuff they need to verify.
You can make sure during that time, make sure your paper has your name on it and all that good stuff, or your initials, your initials and their page number and all that. Again, just want to, we get anxious as we get close to the test, and you shouldn't. It won't be any more difficult to get a 3, 4, or 5 this year than last year. The people in charge of scoring the exams are the same people that were in charge of them last year and the year before, with some minor changes. Well, one major change because chief readers roll over, but it's the same family of people. They're not great on a curve. You're not competing with each other. You're trying to demonstrate you're ready for the next course. And you have to finish all the parts to demonstrate that. So get as much done, show as much as you know, as quick as you can. And that's what you do, right? And in July, you'll find out how you did. I love this quote, by the way. This is one of the main reasons I pulled this slide. I love you're an AP student. You're a brilliant problem. You're here for a reason, right?
Mm-hmm.
And then, check your tech. Make sure you're using the latest version of Chrome, Firefox, Safari, or Edge. Please don't be using Internet Explorer or Netscape or Opera or anything like that. Disable your extensions. This is all on the checklist. You guys need to go online, find that stuff, and do it this weekend. Do it today, do it tomorrow. You don't want to be doing it the day of and running out of time. You know what to expect, correct? That's, oh, who's in the chat?
She's
Hi,
saying,
Claire.
did you say Netscape?
Oh, yes, I
LOL.
did. Yes, I did. So these are the last times for these slides. So we're not going to end on this, but I did want to, Verge hasn't seen all these animations. I put these on here. So, one last time, thanks for watching.
We love you.
Love you and good luck. And going to start a new share. We're going to, and I think this is the right video. We have
So
two
there's
videos to share.
So
I'm actually going to share my screen, which is like dangerous as all get out, but here's what my desktop looks like. Did you want to show these timestamp ones?
Mine is so different. My desktop is such a mess. And
Mine
Mark's
is mine is the end of each quarter, but I've been keeping it clean. This is a video that's probably going to be released online. We just wanted to show off ourselves.
Yeah, so this is a whole bunch of AP teachers from all the different AP subjects, just wishing all the AP students good luck. Yeah, and it's a great video.
All the people that present. Am I sharing the slideshow right now, by the way?
Nope. If you are, I can't see it.
I love that clip because I'm in your kitchen.
So what we wanted to do here is just show you like the parts where we
want to show off ourselves because we enjoy doing it. Hi, Tony.
Thank you so much for watching Mark and me for these last 30, I don't know, however many sessions we had. And if it weren't for you, we wouldn't have had these sessions.
That's right. We wouldn't be here if you guys had all stopped watching
the past month and a half. It's been such a journey and such a treat for me.
Hey, thanks for watching the last 6 weeks, especially the calculus crew.
You guys are awesome.
I told Verge, I'm really glad they cut that short because it got really awkward right after that. I was like,
but I think even scrolling through, you went past the physics guy, so a lot of the AP here. Can you pause that, Mark, for just a sec?
Yes, I can.
Okay, so before we do this one, and we're going to kind of go out on this, although I don't know, maybe we'll still be there at the end. But it's really fun because you guys have been watching a lot of these AP teachers. If you have multiple AP classes, so you got to watch that other video that Mark was sharing there, because it is really, really good. Like the physics guys and all the.
Yeah, it's neat. We just didn't want to end with 12 minutes of videos, so we had to pick one.
So we're going to do calculus. These are all calculus teachers.
Keep an eye out for somebody you may know.
Yep.
Good morning and welcome to the very first YouTube Live virtual lesson for AP Calculus BC.
Yeah.
Okay,
And
well, I'm crying.
I want to just
How
thank
about you,
Tony.
Mark?
I want to thank Tony for putting that together and thank
That was so
the
incredible.
350 some teachers that sent them pictures. In fact, that's the short version. There's like a 9-minute mix they're going to put on Facebook tonight. So
Yeah.
if you've got
So
some time.
so much love. Oh my gosh. Your
and
teachers love you.
I finally remembered, I forgot to use them, but I finally brought my little lightsaber pointers out. Which,
Oh, you did. Shoot, we're gonna have to just have a reunion video. Can we do that?
it's funny. I'm reading my emails while this is going on, and it's buddy. Somebody said that they wanted they're lobbying for us to keep us going as a YouTube series. Give us a week. We'll see.
Here's what I want to do. Well, after we get the exam, which is going to be released 48 hours afterwards, so we've heard. After we get the exam and we work the questions ourselves, which of course we're so excited to do, that's going to be like the best Thursday ever. We need to work it for everybody else. Those who want to watch. If you don't want to know, you don't have to tune in. You know what I mean?
You got other exams to work for. You got your life
That's
to move
true,
on
too.
with. I always love the clip from. After the first or second test, we always have to do this. I have a story time with my kids that about. I do animal crackers, but the other thing I do is the movie clip from Lion King when the baboon hits him in the head and says, "It's in the past." It's Wednesday. It's in the past.
In the past. Just do the best that you can on Tuesday. Like it says in the video, we are already proud of you. I'm already
especially if
thinking
you
of
came to all 33 of these, I'm amazed. Good job. I mean,
when I think about my AP Calculus students, I think about them as like 33-year-old doctors and engineers and teachers and moms and dads. I don't think about them today. I think about them 15 years from now. I really do. So I'm already proud of who you are and who you're going to be.
Yeah. Well said. I hate goodbyes, right? What do you say?
I don't know, but I put on way too much eye makeup for this.
These are your last websites, right? You go to the MyIP, get your profile, go to the demo site, practice uploading the way you're going to upload on your exam. Practice both if you're going to do it different for English Lit or whatever. Go through the checklist, the 5 steps. You guys can read. You've gotten this far.
Yep. Yep.
And there's the last dissolve. So.
Thanks
Bye.
for watching. We love you guys. Do
your
great on
best.
Tuesday.
Don't have to do
Bye.
great. Do your best.
If you're doing your best, you're doing great, right?
Yeah, that's right.